So another example, we're going to try to find the antiderivative of this function. You're going to learn some techniques in Calc 2 next semester that this particular radical will catch your eye because of the 1 minus 5x squared. However, even in Calc 2, the techniques that you're going to learn, you're going to want to use U-Substitution whenever you can. And so what I'm going to do here is I'm going to look at what's under the radical, and I'm going to set that equal to u and see if I can get everything to work out. So we're going to try, let's pick a nice color. Let's try u equals what's under the radical, so 1 minus 5x squared. So then du is just minus 10x dx. And so that means that dx is what? Du divided by negative 10x. And so now when I want to go ahead and try to switch this integral over, I get the integral of x over the square root of just u. This is just x over, let's make that smaller, sorry. X over the square root of u, and then dx becomes du over negative 10x. Now, I just want to point out to you, if you get in a situation where the x's don't cancel, and you're left, after you've canceled everything, you're left with x's and u's, that means your u substitution that you picked doesn't work. You picked the wrong u, and you need to try again, or maybe there isn't a u that works. But in my case, the x's cancel, and so I get negative 1/10, the integral of du over square root of u. Yes, you can do that. This is the same thing, by the way, as negative 1/10 integral 1 over square root of u du. Your book will do this. This is very common to just say, well, 1 times du is du, and actually put it above something when there's a fraction. Not a big deal. Don't let it bother you. Just make sure that you know how to handle it. So we're to this point, and now what you want to do, remember, we're looking for an antiderivative of this function. So I'm just going to come over here, and I'm going to say, okay, this is negative 1/10. I want the indefinite integral of u to the minus 1/2 du, and I know how to handle powers of u. You get minus 1/10 tags along. You get u to the minus 1/2 plus 1, and then you divide by minus 1/2 plus 1. I usually don't write that. I just jump right to it, but I'm trying to show you how it works, plus a constant. So this is, let's see, this is going to be negative 1/10. So I'm going to get negative 1/10, and I'm going to say times u to the positive 1/2 over 1/2 downstairs. The half is going to flip up, and I'm going to have 2 over 10, which is going to give me a fifth. So this is negative 1/5 square root of u plus c. I forgot the plus c on that line. And so now I've got it. I'm going to go back and actually copy the original integral down. I like to do that just so that I can actually summarize. So this integral, what we're saying is negative 1/5 square root of, plug in whatever u was 1 minus 5x squared. So negative 1/5 square root of 1 minus 5x squared plus a c. I'm not going to work it out, but just to be clear, if you took the derivative of this, you should get this, and you will. It all works out. So feel free to check that problem if you have any questions or issues. Let's do another example together. I think we're on number 6. Just counting on these examples. So we have a 3x squared e to the 7x cubed dx. And so please pause the video, see if you can figure out what u is and work this one out. And then once you've made a shot at it, come on back and let's have a look. All right, so for this one, hopefully it's clear to you what u is. This one, u is not too bad. You can just see that's where the function composition is right up here. So I'm going to try u is 7x cubed. So then du is going to be 21x squared dx. So dx is du over 21x squared. And so this problem becomes the integral 3x squared e to the u dx, we know, is du over 21x squared. Cancel those x squareds. Actually, the 3 and the 21 cancel as well. And so you end up with the integral of e to the u over 7 du. I'm going to pull that 7 out. So this is 1 over 7 integral e to the u du. But the antiderivative of e to the u is itself. So you just get e to the u over 7 plus c. And then you remember what u is 7x cubed. So I get, let's write down the original problem. We get that this guy, copy, is equal to e to the 7x cubed e to the u over 7 plus c. And we'll just put an arrow there to indicate our work. Okay, so that's another example for you. I wanted to show you a sneaky trick that comes up sometimes on the next example. So this is example number 7. This is a really good trick to be aware of. It's not trying to be mean, but you need to be able to solve these problems. And so this problem looks like this: 1 plus x over 1 plus x squared plus 3 dx. Okay, well, certainly we can break this up as the integral of 1 plus x over 1 plus x squared dx plus the integral of 3 dx. By the properties of integrals, we said you can break them up term by term. Actually, that's by the properties of derivatives too, right? When you take a derivative, you can break it up over a sum. And so when we're going backwards, the same thing holds. Now, at this point, what I want to do is I want to realize that I'm done with this part. That's just going to be 3x. We'll throw in a c as well. What do I do for this part? This is the tricky part. So we'll come down here and let's rewrite it as 1 plus x over 1 plus x squared dx plus we get 3x from this integral plus a constant. Let's just throw our constant out there. All right, so at this point, if you try and do u equals the bottom, 1 plus x squared, you're going to get du is 2x dx. And try as you may, you don't have that. So when you try and simplify this, dx is du over 2x. You're going to get, 1 plus x over u times du over 2x, and that part doesn't cancel. Can't cancel that. So this particular choice of u doesn't work. And so here's the trick. When you see this plus upstairs, you can actually break it up some more, and you might want to do that in this case. This problem is equal to the integral of 1 over 1 plus x squared plus x over 1 plus x squared. They have the same denominator, so I can just add them up like that. Do we agree? And then I've got plus my 3x plus a c. I'm going to break this up even more as the integral of 1 over 1 plus x squared dx plus the integral of x over 1 plus x squared dx plus 3x plus c. This one you should recognize instantly. What function do you know whose derivative is 1 over 1 plus x squared? Well, that's just arctangent of x. So we've got this one. That's good. This one now, let's try our u sub. Let's try u is 1 plus x squared. So du is 2x dx. And so you're going to get, for this one, you're going to get the integral of, let's see, we're going to have an extra half that kicks out. So we're going to have a half 1 over u du. And so when we work this one out, we're going to get 1 half ln of the absolute value of u, which is going to be 1 half ln of the absolute value of 1 plus x squared. I'll talk about that in a minute. You want to drop those absolute values if the inside is always positive. So let's try and put all this together. This is a lot. I realize that. This function, you know, is just arctan of x. This indefinite integral we worked out and we got to here. We're going to drop the parentheses because the absolute values, because we know that what's inside is always positive. So this is going to be 1 half, not equals, definitely not equals, plus 1 half ln of the parentheses 1 plus x squared. I don't need the absolute value anymore. And then I've also got my plus 3x, and I've got the plus c. Some of you might want to pull that 1/2 inside and make this a radical. That's perfectly fine if you do. I'm not going to. But that's it. That's how you work this thing out. So let me stop this video. I think it's getting rather long. I think I'll do one more short video with a few more examples with you, and then you've got everything that you need.